So in this AGV simulation use case, we are considering a rail yard with several rail tracks. Here you have trains that are unloaded and loaded by rail-mounted gantry cranes. You can see that here in this exemplary layout. Loading and unloading takes place onto or from AGVs. So if a rail car is unloaded, the container is placed on an AGV, and the AGV then drives to one of the storage blocks, choosing one of the storage interchanges that are indicated here by gray points, and this is then based on the utilization of the interchanges. So the AGV picks one of the interchanges randomly if the interchange is preferably less utilized than other interchanges. So it tries to pick interchanges based on the utilization, but the storage blocks themselves have the same probability of being selected. The AGV then arrives at the interchange of the storage block at the RTG interchange, and from there a rubber tie gantry crane and RTG unloads the AGV and places the box in the storage block. So in this case, we're also not considering any restacking of the containers in the storage block. We're just assuming that we can always pick any box that we need from the top and place it on one of the rail cars when we need to load a rail car, and when we are putting away a box in the storage block, we just place it on top of another box in the storage block, or we place the box in an empty spot. So the simulation model considers all of these elements: the RTGs, the RTG interchanges, the RMGs, the RMG interchanges, and the AGVs. And the material flow that is simulated is the internal transport facilitated by these AGVs. But the AGVs, of course, interact with these process points. The process points are the interchanges. In case of the RMGs, one process point or one interchange also represents one equivalent, so one RMG in terms of utilization and availability. And in terms of the RTGs, here you of course have several interchanges. So each interchange is one process point, but each of these process points shares one shared RTG. So in terms of utilization, what will be the bottleneck is the utilization of the RTG. So this material flow, this transport flow facilitated via the AGVs is simulated by this example use case, consuming a framework that I developed for this use case. The framework, the project contains what you can see here. There's a configuration file where you can adjust certain parameters. There's a framework that provides classes for modeling process points and process resources, the AGVs, and also a class for collecting statistics throughout the simulation and for visualizing the statistics at the end of the simulation. There's a tools module that contains standardized plotting functions for plotting the state distribution of the equipments or AGVs, and also for plotting the throughput. Then there is also a tool config file where you can set certain parameters specifically for plotting. And besides from that, the material flow is implemented in the model file. Here you can make customizations if you want to adjust the material flow and all the assumptions that are incorporated here. And the main file basically kicks off the simulation and implements the running model. So kicks off the model with material flows, and then also triggers the plotting at the end of the simulation. There's also a documentation here. The documentation is this PowerPoint that you can see here that basically documents the use case in terms of the layout, the parameters that can be configured in the configuration file, and also documents the attributes or the arguments that you can provide for all of the classes supported by this model. So for the process points, for the AGVs, for the jobs, you can set certain arguments when you implement the simulation model. Here you can of course also do customizations in terms of how you address these attributes. Then there is an example section where I show how I implemented this example use case. And then here you can see the default model output. So for this use case, you can see here, for example, the utilization of the AGVs, of the RNGs, of the RTGs, of the interchange, the RTG interchanges, and you can also see the throughput per AGV, the throughput per RNG. In this underlying framework and in the underlying model implementation, there are also some functions provided for intelligently assigning jobs to AGVs. So there is already default functionality provided for trying to assign a job to an AGV in a way that maximizes overall AGV productivity. So that is also part of the framework, and of course additional customizations can also be made. So you can use this as a template for your individual customization. I hope you find it useful. You can find it in the in the web shop of my blog, Supply Chain Data Analytics, where you can download it with all of the modules and the documentation.